These are the frequently asked questions for Algebra 2 for Section 6.3, Day 2, starting with number 25. And number 25 has a lot to keep track of here. So what we want to do is a little bit of FOIL. First times first is going to give me 15. Then outside times outside, remember you multiply the integer pieces together and any radical pieces get multiplied with other radical pieces. So 3 times negative 6 is negative 18, and then we have the square root of 2. And remember, that is multiplication. When two things sit right next to each other in algebra, that's multiplication. And then inside times inside, negative 4 square roots of 2 times 5. Multiply the integer pieces together, so negative 20 square roots of 2. And then last times last. A lot to keep track of there, but all you do is integer times integer, so negative 4 times negative 6 is plus 24, and then the square root of 2 times the square root of 2 is the square root of 4, which ends up just being 2. So it's kind of the same process as we were talking about with rationalizing the denominator. When you do the square root of 2 times the square root of 2, you're going to get the square root of 2 squared, which is just going to be 2 to the first. So we have 15. And then we have some like terms here because we have like radicals. Negative 18 square roots of 2 and negative 20 square roots of 2 is negative 38 square roots of 2 plus 48. And then we would go ahead and add that 15. So if we do that, we have 63 minus 38 square roots of 2. So again, those are not like terms. One of those has a radical and the other one doesn't. A lot to keep track of. But as long as you go through this slowly and carefully, it'll be just fine. Now let me go after 26. After, of course, I finish off FOIL guy here. There's FOIL guy. Got his ears. And then here's kind of his forehead right in here. Yep, there's FOIL guy. All right. So we're always aiming towards that FOIL guy so that we can figure out that we have everything we need. And in 26, we have the square root of 3 plus the square root of 5 squared. There is addition inside those parentheses. I cannot, absolutely cannot distribute that 2 for a power. That is only distributed when we have pure multiplication or pure division. So what we have to do is remember that powers work with the thing that's closest to their left, which in this case is parentheses. So we have to write 2 of those down and then use FOIL. So first times first, square root of 3 times the square root of 3. Well, that's going to give us 3. Outside times outside. Square root of 3 times the square root of 15 is going to be, square root of 3 times the square root of 5 is going to be the square root of 15. My brain's getting ahead of me again. And then inside times inside gives us the exact same thing. Last times last, the square root of 5 times the square root of 5 is going to be 5. So, a couple of like terms here. We have a 3 and a 5. That'll give us an 8. And then we have a square root of 15 and another square root of 15. So 2 square roots of 15. Again, that one's already simplified. And looking towards FOIL guy there, things have gone well. Number 28. Is problem number 26 on steroids. We have 2 square roots of 5 plus 3 square roots of 2 squared. So again, lots to keep track of. Do this slowly and carefully. You might have to show more steps than you did on number 26. First times first. Well, 2 times 2 is going to give you 4. And the square root of 5 times the square root of 5 is going to give you 5. And then I go to the next term, and the reason I wrote a plus down already is because this has addition in both pieces. Then we're going to do outside times outside. Well, 2 times 3 is 6. Again, I keep saying the answer before I read this out. Then the square root of 5 times the square root of 2 is the square root of 10. Then inside times inside. 3 times 2 is 6. Got to slow down my brain here for a second. Square root of 2 times the square root of 5 is the square root of 10. And then last times last, 3 times 3 is 9. The square root of 2 times the square root of 2 is 2. And then we'll go ahead and do that multiplication. And while I'm at it, I will do some simplifying of my square roots of 10 there. 6 square roots of 10 plus 6 square roots of 10 are 12 square roots of 10. 9 times 2 is 18. And that gives us 38 for the integer portion of this answer. And then 12 square roots of 10 for the radical portion of number 28. Next on the list, number 30. And 30, very similar to the problem I just did, but we notice, hey, wait a minute, those are conjugates. So if those are conjugates, remember, with conjugates, the nice piece is you don't have to do the O and the I of FOIL, because outside times outside and inside times inside are going to cancel out. So first times first here is 16. Outside times outside would be 8 square roots of 3, but inside times inside is a negative 8 square roots of 3. So not even going to bother with that. Then last times last, well, negative 2 times 2 will give you negative 4. The square root of 3 times the square root of 3 will give you 3. And you get 16 minus 12, which is 14. So again, we talked about conjugates in class as a way to eliminate a radical in the denominator. You gotta get a little practice at just using them first in order to make sure that's going to happen. So I look at 31 and I say I like this problem because it is conjugates again. And that just means we need to do first times first and last times last. So first times first is going to give you 2 times 2, which is 4, and the square root of 6 times the square root of 6 is 6. Outside times outside, inside times inside, cancel each other out. Last times last is 8 times 8, which is 64. So we get 24 minus 64, which is, of course, a negative 40. So again, if you're struggling with this, just use FOIL, but hopefully after you do a few of these, you'll notice outside times outside and inside times inside are going to cancel out. Then, the reason for that, the reason that we do that right before we rationalize the denominator is because we need to rationalize that denominator by using that conjugate. So here I have 3 square roots of 3 minus 2. And I know that in order to eliminate the radical in the denominator, I have to multiply that by its conjugate. And its conjugate is going to be 3 square roots of 3 plus 2. You keep the same terms. So you keep the 3 square roots of 3, you keep the 2, but you change the sign in between them. So my focus is going to be on my denominator first. I want to make sure that this is going to work out to be an integer when I get done. So first times first, 3 times 3 is 9, and the square root of 3 times the square root of 3 is 3. Outside times outside, inside times inside, don't need to bother. Last times last, negative 2 times 2 is going to give me negative 4. So that's going to be 27 minus 4, which is 23. So that's good news. Now, on my numerator, I just have to carefully distribute here. So 4 times 3 square roots of 3 is 12 square roots of 3. And then 4 times 2 is 8. Well, I could write that here, but it's not doing anything. So I'll go all the way down here to my final answer and put that on there. And now the only way that I would be able to simplify this is if all the integer portions of this have a common factor. So I start by thinking, okay, 12 and 8, 4 goes into both of those, but it does not go into 23. So that answer is finished. 12 square roots of 3 plus 8 all over 23. And again, that's fabulous because we don't have any radicals in the denominator. That's what we needed to do. So next one, here is number 36. Which is 3 plus the square root of 8 over 2 minus 2 square roots of 8. And I hope while you're writing that one down, you're thinking, hey, wait a minute, that's square root of 8. I could simplify that. And we can. We can do it before or after, and as we talked about in class, it's just a matter of preference to me. I would go ahead and simplify this at this point. Some people that have trouble with radicals will not want to simplify it at this point. So it's up to you how you want to do this one. I am going to go ahead and simplify this first. And the square root of 8 is, of course, the square root of 4 times the square root of 2, which is 2 square roots of 2. So 3 plus 2 square roots of 2 over 2 minus, and then again, I remember, okay, I can do that on the bottom as well. So that's going to be negative 2 times 2 square roots of 2, which will be negative 4 square roots of 2. So now, my conjugate will be a 2 and 4 square roots of 2, however, a plus in the middle. Because that's how I'm going to eliminate that radical in the denominator. And I'm going to focus on that denominator first. First times first is going to give me 4. Outside times outside, inside times inside are a waste of my time. And last times last, negative 4 times 4 is negative 16. The square root of 2 times the square root of 2 is 2. So that's going to give us 4 minus 32, which is a negative 28. Then the next thing we do is we go see what do we have in that numerator, what's going on there. So first times first, 3 times 2 is 6. Outside times outside, plus 12 square roots of 2. Inside times inside, plus 4 square roots of 2. And then last times last, well, the 2 times the 4 is 8. But the square root of 2 times the square root of 2 is going to give me 2. So this is really, I'm going to go ahead and skip a step here, 16. So on the top, I have 6 plus 16, which is 22. And then I have 12 square roots of 2 plus 4 square roots of 2, which is 16 square roots of 2. And I'm going to take that to the end of this problem and realize, hey, I have integers here that can be reduced. 22, 16, 28, 2 will go into all of those. So if I divide by 2, 22 divided by 2 is 11, 16 divided by 2 is 8, and negative 28 divided by 2 is negative 14. And you could write it this way, that's absolutely correct. You could also put the negative on the top of the fraction. Both of those answers would be correct for 36. And actually the top answer is the answer that your book gives. But again, both of those are correct. It's just a matter of preference about where you have your negatives. Some people don't like to have a negative in the denominator, so that would be the second choice that you see here. All right, so small interruption there. Let me get things set up here again. And start this up. All right, so number 42 has has 4 square roots of 216y squared plus 3 square roots of 54y squared. Now, I talked in class yesterday about how when you don't know what that simplest similar radical is going to be, often what we'll try to do is go after the smallest one first to figure out what it could be in order to make this work, which means we're looking for that like radical. So with 54, I'm thinking about perfect squares, and that's the square root of 9 and the square root of 6, so that'll be 3 square roots of 6. So I rewrite this part of it as 3 times 3 square roots of 6. That'll be a 9. And I've got my square root of 6. And then the square root of y squared is going to be y. So I have 9y square roots of 6. What that tells me is, if this is going to work, I need to take 216 and divide it by 6 and get a perfect square. And it does. The square root of 216 is the square root of 36 and 6. So this will be 4 times, well, the square root of 36 is going to be 6. And then we'll have our little square root of 6. and then the square root of y squared is y. So this one out in the front will be 24y square roots of 6. And then in the back, I have that already simplified 9y square roots of 6. So it's kind of an educated sheet. You go through and you think, okay, I want the smaller one here, it's the easier one to work with. What radical will that give me? And in this case, it's the square root of 6. So if we have 24y square roots of 6 and we add 9y square roots of 6, we have 33y square roots of 6. So there's number 42. Then we want to stop and think, and I know it's already done a lot on this problem, but we need to think about whether or not we need the absolute value bars. And in this case, when you go back to the original, you'll see that y was squared underneath both of these radicals. And that means only positives were going to come out of this. Now at the end, if somebody put a -1 into our formula, we would have an answer that's going to be negative. Well, we can't have that. So, absolute value bars around the y, just to ensure that the author's intent when they originally wrote the problem is followed. Then the next one here that I have is number 43. Let me see if I can fit that on here. All right, so this one, I see 3 cubed roots of 16, and I think about that cubed root of 16, and I know that's the cubed root of 8 times the cubed root of 2. So that's going to give me 2 cubed roots of 2. And I have the 3 out in front, so that's going to be 3 times 2 cubed roots of 2, which is 6 cubed roots of 2. Now, that's going to be helpful because I recognize, hey, obviously the smallest radical that I'm going to have, the simplest radical for this is the square root of 2. So hopefully that'll work for the others as well. So let me go after 4 cubed roots of 54 by thinking, hey, I'm going to divide a 2 out and hope I get a perfect cube. And sure enough, this will be the cubed root of 27 and the cubed root of 2. And the cubed root of 27 is, of course, 3. So we'll take 4 times 3 cubed roots of 2, and that will be 12 cubed roots of 2. So a lot of little simplifying taking place here. All right, and then the last one, the cubed root of 128. So we think, all right, 128, if we divide that by 2, we'll get 64. So 64 and 2, well, that's going to give me 4 cubed roots of 2. And I was supposed to add that. So it takes a little doing there to get all of those terms so that we can see our like radical here is the cubed root of 2. We had 6, we subtract 12 of them, and we have a -6. Then we had 4, and we have a -2 cubed roots of 2 for number 43. And in this case, this was all numbers, no variables, so we don't need to worry about checking for absolute value or anything with that one. All right, now let me erase this one and make some room here for the fantastic number 44. Number 44 switches gears and takes us back to multiplication. And what we're doing here is we're multiplying our radicals, our binomial radicals. But I noticed that that square root of 72 is not simplified, and I would want to simplify that before I did the multiplication. So square root of 72 is the square root of 36 times the square root of 2, which is 6 square roots of 2. So this would be 1 plus 6 square roots of 2 times 5 plus the square root of 2. Now you could go ahead and do the multiplication first, but 72 is kind of a big number to be multiplying by again. Your radicals are going to get large, and then it's harder to find the perfect square and all that stuff. So like I said, I normally will simplify first. First times first will give me 5. Outside times outside, 1 times the square root of 2 is 1 square root of 2. Inside times inside is 30 square roots of 2. Last times last is going to be 6, and then the square root of 2 times the square root of 2 is 2. So really, this is 12. and I have 5 plus 12, which is 17, and then I have 1 square root of 2 plus 30 square roots of 2, so 31 square roots of 2, and that is number 44. Again, just a lot to keep track of as you're going through there. Not necessarily the most difficult thing we've ever done, but a lot to keep track of. And that's usually part of why this chapter is difficult for students. You have to keep yourself organized, and every problem is treated differently. 46 has the square root of y plus the square root of 2 times the square root of y minus 7 square roots of 2. So as I'm writing it, I'm thinking, okay, well, all of these are simplified. You know, I can't simplify anymore. And this is not a conjugate because the terms are the square root of 2 and negative 7 square roots of 2. So it's not conjugates. But let's see how this works out. So first times first will get you the square root of y squared. Outside times outside will give you negative 7 square roots of 2y. Inside times inside will give you plus the square root of 2y. Because remember, when you multiply radicals, you can actually do that multiplication underneath the radical symbol. And then last times last will give us negative 7, but the square root of 2 times the square root of 2 will give us 2. So we have the square root of y squared in the front, and that's just y. And then we have a negative 7 square roots of 2y plus 1 square root of 2y, so negative 6 square roots of 2y. And in the back, minus 14. And those are what we end up with. And I know nobody's going to like that because we're sitting there looking at 3 terms. But remember, we can only combine those like terms as we go through here. And those are the like terms we ended up with, like it or not. All right, let me do some erasing here. And go through number 47. So number 47, as I'm writing it down, I'm thinking, whoa, that could use some simplifying. And again, you can wait and do it later, but boy, you're going to get some large numbers that you're finding the radicals of. So the first thing I would do is simplify the square root of 12. It's the square root of 4 times the square root of 3, which is 2 square roots of 3, plus, and then the square root of 72, we just did that in one of the other problems. That's the square root of 36 and the square root of 2. So that is 6 square roots of 2. And then the 2 for the power, you cannot distribute that. There is addition taking place inside these parentheses. So you have to write this down twice and use FOIL. Or if you remember the formula that we have for squaring a binomial, you can do that as well. The formula for the quantity a plus b squared is a squared plus 2ab plus b squared. But most people are just going to do FOIL when they get to this point. So first times first, 2 times 2 is 4. The square root of 3 times the square root of 3 is 3. Then we have outside times outside. That's going to be 12, and then the square root of 3 times the square root of 2 is the square root of 6. Inside times inside, 6 times 2 is 12. Square root of 2 times the square root of 3 is the square root of 6. Last times last, 6 times 6 is 36, and then the square root of 2 times the square root of 2 is 2. So in the front, we have a 12. In the middle, we can combine those two terms and get 24 square roots of 6. And then in the back, we have a 72. So all we have to do here to clean this up is add the 12 and the 72, and we have 84 plus 24 square roots of 6. No variables, so we don't have to do any worrying about absolute value with that. 50 says error analysis, describe the correct the error made while simplifying these expressions. And what I do with these error analysis ones is I just go through the problem and I do it. And then I go back and I take a look at theirs. Otherwise you talk yourself into, hey, they didn't make any mistakes. Yes, they did. So don't focus on what they did. Focus on what you would do to solve the problem. And what we would need to do is rationalize the denominator by using the conjugate 3 plus the square root of 2. And again, focus on your denominator first. First times first is 9. Outside times outside, inside times inside will cancel out. Last times last. Square root of 2 times the square root of 2, well, we have a negative, so it'll be subtraction, and that's going to be the square root of 4, which is 2. So we are going to get 7 as our denominator. Then in our numerator, we do FOIL on that one, and there's a little bit of work here. First times first is 9. Outside times outside is 3 square roots of 2. Inside times inside is 3 square roots of 2. And last times last is a square root of 2 times the square root of 2, which is 2. Now, hopefully you notice this really was a squared, and then we had 2ab, so 2 times 3 times the square root of 2. We're going to get 6 square roots of 2. And then last times last was b squared. So you can use the formula, but FOIL does it too. So we would get 9 plus 2 is 11 plus 6 square roots of 2. Now, you look at their answer. They messed up because they just got 11. So somehow they talked themselves into the fact that the radical was gone. And where they did that is right there. They distributed that power of 2. And you cannot do that. They looked at these two sets of parentheses and said, hey, those are the same thing. So I'm going to write 3 plus the square root of 2 squared, and I'm going to distribute that power of 2. No, you cannot do that. You cannot distribute a power when there is addition inside the parentheses. So what did they do wrong? They didn't follow the order of operations. I mean, that's our golden rule, and they broke it. They didn't follow order of operations. Order of operations tells us those powers have to be applied to the parentheses when you are distributing. You can only have multiplication and division inside the parentheses for the powers. So, order of operations, follow it. 51 says, a scientist found that X grams of metal A is completely oxidized in 2x square roots of 3 seconds, and X grams of metal B is completely oxidized in 6x square roots of 3 seconds. How much faster is metal A oxidized than metal B? Well, we want to find the difference between the two. That's what it means when they say how much faster is metal A than metal B. So what we would need to do is subtract these two. 6x square roots of 3 minus 2x square roots of 3. 6x minus 2x, because we do have like radicals, is 4x square roots of 3. So how much faster? 4x square roots of 3 seconds. We always make sure we're going to put a label on that so that it makes sense when somebody takes a look at our answer. All right, next one. 52 says, describe the possible values of A such that the square root of 72 plus the square root of A will give you a single term. This is what they're asking us to do. They're saying, find numbers for A that would allow you to add these terms together. So, first thing I need to do is simplify that square root of 72. And we actually did that in homework 3 times now. So that's 6 square roots of 2 plus the square root of A. All right, so what could A be? Well, it has to be 2. And then we could just add these two together. But they're saying in general, what would you need for A to make this happen? Well, as long as it would break down to be the square root of 2 times something, then you'd be okay. So you think, okay, well, what numbers would break down if we're talking square roots? Perfect squares. So any perfect square times 2 is what A could be, because that will make it break down into some integer square root of 2. And that's what we would need in order to get one term. That's what would have to be added there. Number 56 is rationalize the denominator and simplify. So 56 says 4 plus the square root of 27. That drives me nuts. I'm going to go ahead and simplify that right now. The square root of 27 is the square root of 9 times the square root of 3, which is 3 square roots of 3. And then on the bottom, we'll have 2 minus 3 times the square root of 27. So 3 times this, which would be 9 square roots of 3. Now, at this point, I generally check to see whether or not I can simplify even further. You know, maybe all the integers have a factor that I can take out. This one does not. So what I have to do is use the conjugate, 2 plus 9 square roots of 3, to rationalize that denominator. So down there in the basement, in the denominator, 2 times 2 is 4. Outside times outside plus inside times inside is going to cancel out. That's by design. We made that happen. Last times last, a negative 9 times 9 is negative 81. And then the square root of 3 times the square root of 3 is 3. So on the bottom there, I have to figure out what I have so that I will have a nice integer answer. So I need 4 minus 81 times 3, and that comes out to a negative 239. Not a fabulous denominator, but you know what? It is not a radical, and that is what we needed. So then we need to do FOIL on our numerator. First times first will give us 8. Outside times outside is 4 times 9 square roots of 3. That's going to be 36 square roots of 3. Inside times inside, 3 square roots of 3 times 2 will be 6 square roots of 3. And then last times last, well, 3 times 9 is 27. Oops, a squishing going on there. And then if we have the square root of 3 times the square root of 3, that's going to be 3. So in the front we have the 8. In the back we have 27 times 3, and that's 81. So to skip a little step here, I'm going to write that as 81. And now I can combine like terms. So 8 plus 81 is 89. 36 square roots of 3 plus 6 square roots of 3 is 42 square roots of 3. And that's done as far as I'm concerned. Like we talked about before, you certainly could distribute the negative to your numerator if you do not like negatives in your denominator. But both of those are great answers. You know, that's what we get. Okay, 60. What a mess we got there, huh? Decimals inside are radicals. Yuck. So 60 has the square root of 2 plus the square root of 6 over the square root of 1.5 plus the square root of 0.5. So I'm just going to go ahead and hit the dusty trail of rationalize the denominator here. Even though they're decimals, we've got the square root of 1.5 minus the square root of 0.5 as our conjugate. All right, so if you were thinking, oh, Cedar Home, this was bad enough, we can always find something harder, can't we? All right, so the next thing we do is we just go ahead and do the multiplication here. I'm thinking these are starting to run together, so let me separate those. In the denominator, we have the square root of 1.5 times the square root of 1.5, which is 1.5. And then when we do last times last, we have a positive square root of 0.5 times a negative 0.5, and that's going to be a negative 0.5. So down here, 1.5 minus 0.5 beautifully comes out to 1, which means whatever we get for our numerator here is truly our answer. So up in the top, it's first times first, the square root of 2 times the square root of 1.5, and 2 times 1.5 is 3, so the square root of 3. Then we do outside times outside, the square root of 2 times the square root, negative square root of 1/2. Well, that's going to be negative 1. Because if you take 2 times 1/2, you get 1, and the square root of that is 1. On the inside piece there, we have 6 times 1.5, those two radicals. Well, that happens to be the square root of 9, which is going to give you 3. And then last times last, we have a negative square root of 0.5 times the square root of 6. So we'll be subtracting, and then 6 times 1/2 is 3. So we have this piece here, oh, almost forgot my radical there. Square root of 6 times the square root of 0.5 is going to give you the square root of 3. So we notice the square root of 3 is going to drop out, and we have negative 1 plus 3, which is 2. 2 over 1, the answer is 2. So it looks awful, but that's a pretty fabulous way of writing 2. Like I told you, math is really, it's a secret code. I mean, that's what we have. A lot of what we do is just mind-boggling stuff that if you know what you're doing, can get you some pretty cool results. So let me go after number 61. Number 61, I see right away they've got the square root of 27 up there. We've just simplified that a bajillion times. So I'm going to go ahead and write that as 3 square roots of 3 minus the square root of 5, and that is over the square root of 15 minus 3. So this is again about conjugates. So I'm going to use the square root of 15 plus 3. Because that is the conjugate for my denominator. And I'm going to do that denominator first. Square root of 15 times the square root of 15 is going to give me 15. Outside times outside, inside times inside. By design, we don't need to do. And then negative 3 times 3 is, I don't know why I wrote a plus there, negative 9. And then we have 15 minus 9 is 6. All right, so now we go after our numerator, which it doesn't appear is going to end up being very nice. But, you know, we'll do the math and we'll see what happens. We have 3 square roots of 3 times the square root of 15. So that's going to be 3 square roots of 45. Then we have outside times outside. 3 square roots of 3 times 3 is plus 9 square roots of 3. Inside times inside. We have the negative square root of 5 times the square root of 15, that is the negative square root of 75. And then last times last, a negative square root of 5 times, we have 3. So that will be minus 3 square roots of 5. And this one's going to have some simplifying that we need to do. So take a look at this, and I see I've got 45, and that could be split up. 75, that can be split up. So what I have to do now, I'm going to put a little box here, is just simplify these pieces. So 3 square roots of 45 is the same thing as 3 times the square root of 9 times the square root of 5. And that's 3 times 3 square roots of 5, which is 9 square roots of 5. So we have 9. I better switch colors so you guys can see where things started changing. All right, so we've got 9 square roots of 5 plus 9 square roots of 3, and then we have to go after that square root of 75. And the square root of 75 is the square root of 25 times the square root of 3, which is 5 square roots of 3. So minus 5 square roots of 3, at least we have 2 like terms there that we can deal with. And we've got the negative 3 square roots of 5 in the back. And that's what I meant by the 2 different sets of like terms that we have there. That's kind of hard to see because I'm squishing that in there. Hang on here. There we go. That's a little better and a little clearer. All right, so 9 square roots of 5 minus 3 square roots of 5 is 6 square roots of 5. And then we have 9 square roots of 3 minus 5 square roots of 3, which is going to be plus 4 square roots of 3, all over 6. Now, check out the integers. 6, 4, and 6. 2 goes into all of those. So we need to reduce the integers, not the radicals. Doesn't work that way. Just the integer portions of all of this. So that'll be 3 square roots of 5 plus 2 square roots of 3, all over 3. Boy, that was a beautiful problem. There's a lot of good math that took place in there. And that will do it.